This is homework 6, question 1. And question 1 asks about when x and y have a joint density function. So the joint density function fxy xy is equal to 1 plus xy over a. And the absolute value of x smaller than 1 and absolute value of y smaller than 1 and 0 otherwise. And for subproblem 1, ask about find a so that it is a valid joint density function. So for a valid joint density function, when we integral fxy xy by dx dy, we have the area, we have the value 1. So by integrating x and integrating y, we have 1. So for the range of y for integral, it is from the lowercase -1 to uppercase 1, and for x is the same, lowercase -1 uppercase 1, and the fxxy is equal to 1 over xy over a, 1 plus xy over a. So we can write like this: 1 over a square plus 1 plus xy dy dx is equal to 1. So when we integral dy y, we can get that it is 1 changed to y plus xy squared divided by 2 in the range of -1 to 1, and 1 over a is equal to 1. And similarly for integral of x, we can get so this one, we can get that when y is equal to 1 is 1 plus x squared 1 plus x over 2 and minus 1 plus x over 2, and integral this is equal to 1. And for this part we can get is 2, so it's 2 over a integral through the x is equal to 1, and we integral this, get 2x over a in the range of -1 to 1 is equal to a. So it is 4 over a is equal to 1, and a is equal to 4. And subproblem 2 asks about are x and y uncorrelated? Show and prove. So if we want to prove x, y are uncorrelated, we have the theorem that the exy is equal to ex times ey. So this is how to prove it is uncorrelated. And for exy, we can get integral of y, integral of x, and xy, and fxy is 1 plus xy over 4 dx dy. And the range is the same, so absolute value x is less than 1, so -1 to 1, -1 to 1. And we can get that the xy 1 plus xy over 4 is xy plus x squared y squared over 4, and integral this. So we move out 1 over 4 to the outside of the bracket, so it is 1 over 4 integral -1 to 1 integral -1 to 1 x y, and we can break to 2, so one part is xy dx dy and another part is x squared y squared dx dy. So this part we can write x squared y divided by 2 in the range of -1 to 1, and integral of y, and this part integral of x, we can get x to the power of 3 y squared divided by 3 in the range of -1 to 1, and also need to integral over y. So this part we can write to this part 1, so 1 y over 2 minus minus y over 2. So it is y, and integral of y is y over 2 divided by 2 in the range of -1 to 1, and this is 2 times y to the power of 3 divided by 9 in the range of -1 to 1. So we can get final answer is 1 over 9 for exy, and e of x is equal to integral of x times fxy dx dy. So it is equal to, so this is x plus x squared y over 4, so move out 1 over 4, so x and x squared y, and we can get that through integration the final answer is exy is equal to 0. So e of xy is equal to 1 over 4, which is clearly not equal to e of x times e of y, which is equal to 0. So x and y are correlated, so they are not uncorrelated. And question 3 asks about are x and y independent. So we have, because x and y are not uncorrelated, so which turns out x and y are not independent. And question 4 asks about find the joint density function of x squared and y squared. So we can write that the joint density function of x squared, y squared, z is equal to x squared, w is equal to y squared. So j of it is equal to absolute value of the matrix. Differentiate of z by dx and differentiate z by dy, and d omega divided by dx, d omega divided by dy. So this part is 2x, this part is 2y, the other is 0. So a times d minus c times b, so it's 4xy. J is equal to 4xy. So this is absolute. So 4xy, because and z is equal to the range of z, because absolute value of x is less than 1, absolute value of y is less than 1, so square of it, the range is gonna be z is less than 1, bigger than 0, w is less than 1, bigger than 0. And we can see that because z is x squared, so x gonna be root of square root of z, so it's gonna be 4 roots for plus x squared plus square root of x minus square root of x plus square root of y minus square root of y, so gonna be 4 roots. So absolute value of j is gonna be 4 times, because it's 4 times xy, so x is equal to square root of z and y is equal to square root of w, so 4 square root z square root w, I is equal to 1, 2, 3, 4. And for f, ask about the joint density function. So the joint density function of x squared, y squared is equal to f z w of z w is equal to f xy, xy, and x in the brackets xy can be written as square root z square root w divided by the first absolute value of j, and the second situation when x is negative, so minus square root z and positive square root of x w, and the third situation is when y is negative, x is positive, fourth is x is negative, y is negative. So by adding them together, we can get that 1 over 4 square root z square root w times 1 over 4 these, and this is equal to 4, so these cancels each other. So it is equal to 1 over 4 square root z square root w. And so this is in the range of z is in the 0 to 1 range, w is in the 0 to 1 range. If it's out of range, when z is less than 0 or z is larger than 1 and w is less than 0, w is larger than 1, the joint density function is going to be 0. So we can write as is. And to prove that, the fifth question asks about proof and disproof x squared and y squared are independent. So the fz of z can be written as 1 over 2 square root z when z is in the range of 0 to 1. And fw of w can be written as 1 over 2 square root w. So this part, 1 over 4 square root z square root w is equal to fz times fw. So they are uncorrelated. And because they are joint normal, so they are independent. So this is question 1.